In this video I'm going to have a look at a technique that you can use if you want to draw straight line graphs. This will be equally applicable to both sketches, if you want to use it with sketches of straight line graphs, or indeed you can use it for accurate straight line graphs. And it basically hinges upon you finding 2 points, and the 2 points that you're going to find to be able to draw the straight line are going to be where the straight line crosses the x-axis and where the straight line crosses the y-axis. And then obviously if you join up those 2 points you'll get a picture of your straight line. Now the actual method that this depends upon is very straightforward. For example, if I take number 1, we've got y equals 3x plus 6, which is a straight line graph. Now whenever you have, if I just draw a little sketch of some axes over here, wherever the straight line crosses the y-axis, if you consider that point there, let's say that was a reading of 2 on the y-axis, then the coordinate would be 0, 2. If the straight line crossed at that point there, where that was say 4 on the y-axis, then the coordinate would be 0, 4. If the straight line crosses down here, which was say minus 3 on the y-axis, then the coordinate would be 0, minus 3. So basically it doesn't matter where the straight line crosses the y-axis, no matter where it is, you can see that the x-coordinate will always be 0. Always be 0. 0, something. That's going to be the coordinate that crosses the x-axis at. 0, something. So with that in mind, we make use of that fact to do the following method. So here's a straight line graph. It's a very easy one, y equals 3x plus 6. I'm going to employ this technique to help us work out where this line crosses the axes. I have now shown you this little technique over here. So what I'm going to say is this. The line crosses the y-axis. Now, wherever it crosses the y-axis, I've just shown you the x-coordinate must be 0, 0, something. So I say line crosses y-axis when the x value must be equal to 0. And all you've got to do is replace x with 0 in the actual equation that you're talking about. So in this particular case, you get y equals 3 zeros plus 6. So you get y equals, well, if you work that out, you just get 6. So it crosses the y-axis at 6. Now, because it was such an easy straight line equation, you could probably deduce that straight away because it's got a plus 6 on the end. And you should know from previous videos on straight line graph work that the number on the end, when it's written in the form y equals so many x plus a number, the number on the end tells you where it crosses the y-axis. So that just confirms that this method does give you the right answer. Okay, so if I now want to do the following, line crosses the x-axis, well, by the same sort of argument, if the line crosses the y-axis when the x-coordinate is 0, then by the same sort of argument, the line will cross the x-axis when the y value is 0. So for example, on this picture up here, if it crosses the x-axis there, let's say that was a minus 4 on the x-axis, then its coordinate would be minus 4, 0. So wherever it crosses the x-axis, the y value will be 0. So we make use of that and say this, line crosses x-axis when the y value is equal to 0. So we take the equation that we're talking about, the name of the line we're talking about, and everywhere you see a y, you change it to 0. So y becomes 0, and we get equals 3x plus 6. So by doing this, we set up a little equation we can solve to find the x value. So 0 equals 3x plus 6. Take the 6 to the other side, you get minus 6 is equal to 3x. Divide both sides by 3, and you get minus 2 equals x. Minus 6 shared by 3, minus 2. So I now know the 2 places where this straight line crosses the axes. Y equals 6 and x equals minus 2. So if I wanted to do this as a sketch, I will do a small picture here to sketch this situation. Y and x axis, minus 2, mark on minus 2 say there, that's where it crosses the x axis, crosses the y axis at 6, I'll put 6 there. It's only a sketch, so I'm not doing an accurate scale, and just draw a straight line joining up those 2 points. That wasn't a very good straight line, and it's as simple as that, really. Of course, if you want to do an accurate picture, then you just do an accurate scale and very carefully mark it out, plot the points and join them up. So I'll try and do a better picture this time. There we go. There's the y-axis, and there's a sketch of this particular straight line that we're talking about. Okay, so let's have a look at question number 2. I'm going to speed up and see if this all makes sense now. So if I get rid of all of this, and for number 2 I'm going to say this. How about y equals minus 5x plus 3? I've got to find for this where this crosses the x and the y axis very quickly. So I'm going to say this. Line crosses y axis when x equals 0. So everywhere you see an x, change it to 0. So the y value equals minus 5 times 0. So minus 5 times 0 plus 3. Well, minus 5 times 0 is 0, add 3, you get the 3 as an answer. Which does make sense because we've got a plus 3 on the end, and it is in the form y equals so many x's and a number. So if you like, for this particular one, you didn't really need to do that step there, because you can just look at the plus 3 and say, well, I know it crosses a plus 3. But I am doing this method to show you it does work, even for this easy example. Line crosses x-axis now, and you need to say, well, it crosses the x-axis when the y value will be 0. So that's the standard phrase you need to use, and you need to tell the examiner and write it in when you're doing an exam question. Okay, so we take y equals 0 now and put it into there. So 0 on the left equals minus 5x's plus 3. There's a little linear equation we can now solve. So take the minus 5x, I don't like the minus there, so I'm going to take that to the left to make it plus 5x. And we've got a 3 on the right hand side. Divide by 5, so divide that by 5. Well, 3 shared by 5, I'm not going to use 0.6 decimal, I'm going to leave it as the fraction 3/5. So what we've got there are 2 places which I can now show on a sketch. Remember, you could do an accurate diagram if you so choose. I'm just doing a quick sketch here. X equals 3/5, so you go to 3/5 somewhere here on the x-axis. I'm not marking in 1, 2, 3 or anything, just plonking 3/5 on the sketch. And y equals 3. Something up here, y equals 3, and then you just join them up. Something like that, with a straight edge, and there you go. And if you think about it, the slope of this from the original picture, y equals minus 5x, should be a negative 5 slope. And so it should, you are expecting it to be going that way, which is a negative slope. Okay, so I've done 2 basic ones using this technique, but sometimes the equation of the straight line looks a bit harder. And when we have harder ones, people sometimes don't like them, as I'll show you in number 3. Just watch what happens with this one. Number 3 now, what we've got is 2x's plus 3y's are equal to 6. Now, many people looking at that would not recognise that perhaps as a straight line graph, because they normally see straight line graphs as written y equals so many x's and then a number on the end. Now you can quite clearly see that that does not look like that. Now, one way that you could deal with this to plot a straight line graph is to use what I call the change of subject method. In other words, you could rearrange the algebra to get y on its own and then use a table of values if you wanted to, like you would plot if you're doing an accurate picture of a straight line graph. So you could do this. You could leave the 3y on its own, take the 2x over, you're going to get minus 2x, and leave the plus 6 on the right, you get that. Then I'm going to share every single term by 3. So share that by 3, share that by 3, and share that by 3. You're allowed to do that as long as you share every single term by 3. So the original straight line equation, which is that, is actually the same as that. And this process here is known as changing the subject. So now you've got it in the form y equals minus 2/3 x plus 2. If you wanted an accurate picture, you could do a table of values for that if you wanted. Or, if you want, you could at that stage use this crossing x-axis, crossing y-axis technique on that equation, like I did in question 1 and question 2 for that sort of equation. However, the beauty of this method that I'm showing you is you can apply line crosses x-axis when y equals 0 to the original format of the straight line equation. You do not need to rearrange it with change of subject to get that format. And you will get the right answer. So if I look at this, I'm going to say straight away, line crosses x-axis, I'll do y-axis to be consistent, y-axis when, and I'm going to say when x is nothing. So what you do is you take the equation and everywhere you see an x you change it to nothing. So you get on the left 2 nothings plus 3 y's are equal to 6. 2 nothings are nothing, so you end up with 3 y's are equal to 6. Share both sides by 3, you get y equals 2. So straight away I can see it crosses the y-axis at 2. Secondly, I'm going to say line crosses the x-axis when, well, it's when y equals 0, if you remember what we talked about in the previous examples. So you take the original equation up here, and everywhere you see a y, you change that to 0. So this will become 2x's plus 3 zeros are equal to 6. So you get 2x's are equal to 6. Divide by 2, x must be equal to 3. And so there you go, we've found the 2 places where the line intersects the x and y axis. And so we can do a nice sketch. So I'm just going to draw the sketch in this region down here. It's not a big sketch, remember, you could do an accurate picture if you wanted to. Y and x axis, x equals 3, just mark on a 3 on the x axis. Y equals 2, just mark a 2 on the y axis. Join them up and you've got your straight line for 2x plus 3y equals 6. And it's as simple as that. So, a very useful technique. I'm going to do one more, another awkward one like this. Remember, you can do accurate straight line graphs if you want to. It just means setting up an accurate scale to plot the 2 points. That's all. So, no table of values necessary for this particular technique if you're doing an accurate picture. So, number 4, last one, very quickly. And let's have a look at this one. Number 4 is 5x minus 2y is equal to 1. Okay, now if I was to do that using a change of subject method to get y on its own, I think that would be an awkward way of doing things, because you'd end up with fractions involved if you actually tried to do it. I'm not going to do it, but you would have fractions involved. And doing a table of values with those fractions might catch a few people out. But if you're going to do it by this technique, it's really straightforward to get either a sketch or an accurate picture of the straight line. What I'm going to say is that the line crosses the x-axis. I'll do x-axis. It doesn't matter whether you do x or y first. The x-axis when y equals 0. So, look at this. 5x minus 2 noughts. Well, I'm going to save a line here. 2 noughts are 0, so that doesn't change anything. That becomes nothing there. So I'll just get 5x. And that will be equal to 1. Divide by 5, so divide that by 5. So there you go. X equals 1/5 is where it crosses the x-axis. Next, line crosses the y-axis when the x value will be 0. So you just take the original equation and everywhere you see an x, change it to 0. So you get 5 noughts. That's nothing. Minus 2y equals 1. So we end up with a little equation in y that we need to solve. Now, many ways of solving this. What I'm going to do is simply say take the minus 2y to the right, make it plus, take the 1 to the left, make it minus 1. So I get to there. Divide both sides by 2, you get minus a half is equal to y. So you can see we're getting fractions coming out, and they're not very nice fractions, minus a half, 1/5. which if you'd done it by change of subject method with a table of values to do an accurate plot would be quite awkward, and you'd have to be confident with how you can work through with fractions. But using this method, yes, you get the fractions, but you only get them right at the last line, and they're very simple to work out. Okay, so what does the sketch look like? So very quickly, if you want to do an accurate picture, you can do so. I'm just going to put on -1/2 somewhere down here on the y-axis at -1/2, that's where it crosses, and at 1/5 plus 1/5 on the x, I don't know, somewhere there, 1/5, that's where it would cross on the x-axis. Join them up and you end up with a straight line that looks like that. And that is how you draw straight line graphs using 2 points where the 2 points are located on the x and the y axis. It's a very, very handy little tool to have in your tool bag for future reference, and a mathematician would often use it instead of going through the table of values method if they're doing an accurate picture of a straight line graph. That's the end of this video.